Okay, for configuration, I have configured some of the stuff here. We have a router A. These are the configuration for router A. Interface FA00, IP address 10.1.1.1 with the /8 or subnet mask 255.0.0.0. No shutdown. Then interface serial 000, which is this interface, with IP address 192.168.100.1, this subnet. And then I configured the IP route or static route, all zeros towards that interface, 192.168.100.3. Similar configuration on router B, interface FA00, that interface, IP address 10.1.1.1.2, with the subnet mask 255.0.0.0, no shutdown, and then serial 001, which is that interface, with IP address 192.168.200.2 on that network. And then I configured the static route as well. Everything, the default route, to go to that interface or to the ISP's route. I did configuration for ISP here. Interface FA00, which goes to this DNS, ccna.com. And then the interface 000, which goes to router A, 192.168.100.3. And then interface serial 001, which goes to router B, 192, IP address 192.168.200.3. And on the ISP, I configured two static routes, saying IP route network 10.0.0.0 with this mask. It goes to router B, and the other one to router A. So two default routes. Here I have a server here called ccna.com. It has a DNS as well. The IP address is 172.16.1.100. That's the subnet mask, class B, and then the gateway 172.16.1.1, which is this router or the ISP router. Down here we have three PCs. IP address 10.1.1.1.1 for this PC, the subnet mask /8, and the gateway 10.1.1.1, and the same the gateway for the second PC and PC3. So all the packets, they're gonna go from this switch towards the router A and then to the internet. Everything is fine, but if it goes down, this link here, if it breaks, then there's a problem. This link, if it goes down, then there's a problem because all the packets will be dropped. While we have a fully working link on this side, well, we're not utilizing it because the gateway says we should go towards router A. Okay, now I'm going to create three packets going from PC to this server. I'm going to ping that server. So create packet PC1 to the server, and another from PC2 to this server, and from PC3 to this server. Now three packets are ready. I'm going to auto capture this, and as you can see, all the packets are going to go on this link because that's the gateway 10.1.1.1. So they're not going to utilize this link at all whatsoever. Okay. And then the packets are going to come. Well, you can see the ISP is doing the load balancing because we created a static route pointing to both of the routers. So PC1 just received it successfully, PC2 is receiving it, and PC3 has got a successful ping as well. Okay, great. Now that worked very well. Now what we're going to do here is we're going to go to the PC to router A, and we're going to shut down this interface and see what happens. So go to router A, Cisco here, and show IP interface brief. Yep, this interface, we're going to shut that down. So go to config T, interface FA00, shut. So that interface has just been shut down, and I'm going to create the three packets again to the switch, to the server here, and we can see the PCs are all going to attempt to send the packets that way, but it's not working. Okay, so all the packets have failed from all three PCs. Okay, I'm gonna bring the link back up, so no shutdown. Okay. Okay, what we're gonna do now is create a standby or this virtual router here. Now what I'm gonna open Notepad here, and the commands, we need to go to the interface. So say this is configuration for router A, interface FA00, and then we already have an IP address, so we just need to create a virtual router. We create a group, so that becomes the standby group 1, and then the IP address of the virtual router. So in this case, say 10.1.1.10. Then standby 1, then we can say the priority 10, or say 110. The default is 100. A higher priority is going to become the active router, and standby 1 preempt. Okay, now this with these commands we actually configure this virtual router. We do similar commands for router B as well, so I go there, same commands. Okay, now if I do the priority 110 here on this side, they're both going to have the highest IP address is going to win the election. So on this side I'm just going to delete that command, so I'm going to leave it to default. Okay, so Control C, copy, and paste this. So standby 1 IP address, standby 1 priority, and standby 1 preempt. If I go to the notepad again, and this is gonna be for router B, copy that, and open the router B. Config T, and then paste that. Okay, now what we have to do is we have to go to the client machine and change the gateway to from 1 to 10. So change this gateway here from 1 to 10 on each machine. Okay, so go inside the PC in configuration and change the gateway to 10. PC2, the gateway to 10.1.1.10, and then PC3 again the gateway 10.1.1.10. Okay, now they have a default gateway has changed to 10 to this virtual router. It's going to be sitting, these two routers they're going to keep alive. Okay, so as you can see, the router A has become in the standby first, and then from standby has used to active. So to see the commands is show standby 1, or just show standby. We can see that in the fast Ethernet is group 1 we are using. State is active. Then the virtual IP address for the router or virtual router is 10.1.1.10. Active virtual MAC address is this. Then hello time is every 3 seconds. Hold time is 10 seconds. Next hello in less than a second. And preemption is enabled. Active router is a local router. We repeat the command in router B to end and show standby. You can see there in state for this router is a standby. Active router is the neighbor router. Okay, so now all these clients, because he's the active router, all the packets are going to go this way until this fails, this interface fails, and then if that interface fails, this router will become the active router, and all the packets they're going to start traveling that way. But the clients, they don't know that. The clients are just going to send to the real to the default gateway they have. Okay, so I'm going to open the PC1, open the command prompt, and start pinging. If I can just go this way so I can arrange it. So ping that server 172.16.1.100, and I'm going to send say 1,000 packets. Getting replies here. All the packets, if we look in the simulation, all the packets are traveling that way. You can see now, I'll open the router A as well. At the same time, I'll keep PC2 as well. Sorry, PC1 and router A on the same window. Okay, the replies are happening here. So if I go to router A and I shut down the interface, so interface FA00 shut down. Okay, we can see from router A now how many packets they're gonna drop, and until router B takes over. Okay, we dropped 2 packets, and now router B has just taken over. All the packets are flowing because you can see that link is red, so it's not working. So all the packets are just flowing that way. Okay, because we have the preempt word, the state has gone to initialize state, but when we bring the packet back up or the port up, then it's going to go to active state. So no shut down. So you can see that right away after we change the state to up, it's gone from standby to active because of the preempt word. You can see we just dropped 1 packet in this case. Right, so if I shut down, now the packets are going to start flowing towards router B. It's going to go that way. We lost 1 packet. If I bring the port back up, now it's going to go towards router A. Yeah, we dropped 1 packet. Okay, thank you very much for watching. This has been Astrid Krasniqi showing you how to configure HSRP. Goodbye.